So we're going to do the circles packet. Okay, so if you can get that out of your box, and also science passage. And we'll wait a minute to see if Sophia's going to be on board. Margot is going to watch this later. Thank you.
It's not quite ready. No, but I think they're bigger than this. We have.
We'll just wait a couple minutes.
Yeah, we have a couple.
How was your school day?
All fresh. Sure.
Oh, thanks. I'm glad you had a good day. So this math is not as bad as that math we had on Sunday. I apologize that was so intensive. When I did it online earlier on Saturday, it went over 20 minutes, and I didn't want to keep you guys over, but then I realized that was like going over 9 months of math in a blitzkrieg. So we'll just wait 3 more minutes, see if Sophia shows up. So we're starting the geometry tonight. When did you have geometry, Haley? 9th grade? Was it 2 years ago or 1 year ago that you had geometry?
I did science.
Yeah. And tomorrow. Oh, wow. That's pretty hard. What school do you go to? I forget. That had to be hard. Oh, that's right. Okay, well, we'll start, and Sophia and Margot's going to watch this later, but anyway, if you go to a formula page, Haley, that had to be a hard math year, too, or Algebra 2 and geometry. If you go to a formula page, and I'm going to look at, doesn't matter which one, I'm going to be on 458. And so the first figure we're just going to look at the circle tonight. And so they give you two formulas. Area is pi r squared, and the circumference is 2 pi r. And also down in the bottom it says degrees in a circle is 360, and radians is 2 pi. So we had to decide whether to go with triangles or circles first. And since they put circles first, we'll start with circles. So let's go to the packet, and we'll go to the first page. So we're going to start slow like we do always. So the good thing you don't have to know any proofs. You pretty much just have to get lengths, areas. So the radius is anything that goes from the center of a circle to the outside. I just drew the picture. And the longest chord you can draw in a circle is the diameter. And so 2 radii equal the diameter. Okay. And this is something they might test on. A line tangent to a circle is perpendicular at the point of tangency. And that's not trig. So the only trig you have to know we're going to be doing in class on Sunday. So it's just 2 packets to cover the whole geometry. So instead of going through a big 400-page geometry book, you're just doing 2 packets. Also, they usually keep these in terms of pi in the answer choices. So let's do this first one. If the radius is 2, the diameter would be twice that, or 4. The circumference you could also think of as pi d or 2 pi r. So the circumference would be 4 pi. That's what I mean about they keep the answers in terms of pi. And so pi r squared here would just be 4 pi. Okay, so if you would just fill in the chart, and then we'll go over it. I just want you to try to, no matter what they give you, You just have to calculate to yourself, get the radius, and then everything else will fall in line. Oh, Sophia, glad you're here, hon. Thank you so much for letting me know. So we're in the circle packet and we're just filling out this chart. Sophia, can you tell me, is your dad going to be singing at the Steeler game this coming Sunday? I wanted to watch it and I wanted to know if it was this coming Sunday. He told me a date, but I didn't write it down. Oh, good. Okay. That's so exciting. That's so exciting. Okay. So we're filling out this chart. And so if the diameter is 6, the radius would be 3. The circumference would be 6 pi. In the area, we have to square the radius. That would be 9 pi. So if they give you the circumference is 10 pi, that means the diameter is 10, the radius is 5, and the area would be 25 pi. Now this is the tricky one. 16 pi would be pi r squared. So the radius would be the square root of 16. So the radius would be 4, the diameter would be 8, and then the circumference is 8 pi. So if that makes sense, just put, girls, if you would just put makes sense in the chat room. Just write this in the chat room if this chart makes sense. Okay, so Sophia's got it. Okay, great. Now let's go to the next page. So we're starting pretty slow. So the same thing here, because they'll usually give you a picture. So what I like you to do, you know, the formulas are pi d or 2 pi r, and the area is pi r squared, and they give you those, but okay. So fill out this page, and then we'll go over them. Take your time. This is a review of geometry, which you probably had quite a while ago. So this math lesson isn't that hard. We don't have to know the unit circle, so we're just going to cross that off when we get to those pages. So like I said, when this first test first came out a while ago now, it's hard to believe it was a while ago, we sort of over-prepared or over-anticipated everything. Okay, so we're going to go through this now. So if the circumference is 24 pi, That means the radius is 12, the diameter is 24, and the area is 144 pi. So number 2 is pretty easy because they gave us the radius. So the diameter would be 8, the circumference would be 8 pi, and then the area would be 64 pi. Sorry. Okay, number 3. That means the radius would be 6, the circumference would be 12 pi, and the area would be 36 pi. And the last one, if the area is 64 pi, that's pi r squared. So the radius is 8, the diameter would be 16, and the circumference would be 16 pi. So if that makes sense, if you would just say that again, and then we'll start into some harder things. But I just wanted to get that foundation. Like I said, we're going to do the triangles and all the, so just put makes sense in the chat room so I know you girls are good out there. Oh, thanks, Sophia. Great. Okay, now let's go to some harder questions using what we have so far. So, if the area of a circle is 36 pi, we know that equals pi r squared. So we know that r squared is 36. And we know the radius is 6. I still don't know, Haley, how you did Algebra 2 and Geometry in 1 year. Whew. And it had to be brutal. Because there's homework usually every night with math, or every other night. Okay, this one is a little difficult, so I'm taking you into a harder question. These 4 circles are the same size, and each circle is tangent to. And that has nothing to do with trig. We're going to do the trig next week. Tangent just means touching. In this case. So the centers are the vertices of the smaller square. The area of the smaller square is 9. So on harder geometry, it might be multi-step. So the geometry, they'll be peppered through the test. They're not going to be a big chunk like the polynomials were last week. So if this is 9, that would be 3 times 3. So each of these sides is 3. So this would be 1.5. Whoops. It's hard to write on this vertical surface. Whoa. That would be 1.5. This would be 1.5. And that, so each of these radii would be 1.5. And how I got that was I had to go for the center of the square and work outward. So that means this bigger square has to be 1.5 times 4, or each side of the square is 6, and so the area of the larger square has to be 36. So if you see 2, if you just put that in the chat room. Great. So again, it might not be, if you have a question, just put a question mark because we're just a little family here. Good, Sophia. Now I had to decide whether to do triangles or circles. And because circles came first in the formula sheet, that's why we did that today. So in the figure below, we have a semicircle and a right triangle. What's the area of the composite figure? So that means the triangle plus half the circle. Well, the area of a triangle, we'll do this next week. It's just, or on the weekend, it'll be 1/2 2 times 2. So that's not too bad. 1/2 of 4 is 2. Now, this is the hard thing because we have to get the radius. What we can do, we can use the Pythagorean Theorem and get the diameter. But after next week, so I'm going to take out the perfects. Remember, we did the radical lesson. I can make a marriage of 2's. That would be 2 square root of 2 for the whole thing. But I only need half of it, so I just need 1/2 pi square root of 2 squared. So that cancels that. And 1/2 of 2 will just be pi. So that real hard one will be pi plus 2. So if you sort of followed with 3, just put C3. And if you didn't see it, let me know. Put a question mark, like how did you get the... After the triangle lesson, you're going to know that's an isosceles triangle. Because Haley told me she did 2 maths in 10th grade, which I can't believe that. Sophia, when did you have geometry? Last year or 2 years ago? Oh, good. You both see it. I just don't want to go too fast. Okay, so on to the next page. Okay, so if they give you a shaded area problem, we can't get the dimensions of that shaded part. But what we can do, we know every side is 2 and it's a square. So we can take the area of the square. Oh, freshman year, Sophia. So it's been a while. It's been 2 years for you too. So these 2 packets will cover everything. So the area of this square will just be 2 times 2 or 4. And then all I have to do is take away half the circle. Do you see that? So the radius would be 1. And I just have to take 4 minus 1/2 pi 1 squared. That'll just be 4 minus 1/2 pi, or 4 minus pi over 2, which is answer choice C. So this one would be taking away the whole circle, and so some kids might fall into that. So if you see 4, you can just let me know, or if there was a question on how I got the radius or anything like this, let me know, because both of you took geometry 2 years ago, and it's pretty hard to dive into it if you haven't done it for 2 years. So Sophia's good. Haley sees it too, great. Now this one is hard. I've seen ones like this where they did frames that were concentric, and you had to get this frame and then maybe this outer frame. So I wanted to get one like this, because like I said, thank God there's no proofs. That's the worst part of geometry, I think. In the figure above, the 4 circles have the same center. And the radii are 1, 2, 3, and 4, respectively. So when they list them respectively, you can see the little guy is 1, 2, 3, 4. We want to get the small ring to the big ring. Okay, well, let's look at the small ring. So if I focus on the small ring, I'm going to take this 2, I'm going to take this whole thing, let me draw it out here, which is 2, and then I'm going to take it minus the whole, which is 1. So 2 squared pi, this whole donut hole will be 4 pi minus the little donut hole, the donut, minus 1 pi. And so the small ring, the donut there, would be 3 pi. This is a hard one to see. I'm sort of stretching you a little bit. Then this one, what I'm going to do is take the big ring, which has a radius of 4, which would be 16 pi, minus this whole, let me see if I can make that red. This whole hole we're taking out, which is 3 pi, which will be 9 pi. And so we'll get 7 pi for the outer ring, the large one. And this is the small one. And so the small to the larger will be 3 to 7. A lot of kids would pick 1 to 4. So I don't, usually nobody sees this the first time. So let me just see if you see 5 or if you have a question. If you have a question, I can understand that because usually people don't catch this right away. But this is if they give you a frame, it'd be the same thing. You take the outer dimensions minus the guts of it. So we just need a C5 in the chat room or I don't get it. Okay, so Haley sees it. Again, this is just bringing up all the geometry you need to know to the forefront of your brain for the test, and I think it's like 3 weeks now or something like that. Oh, and Sophia sees it. Yay, math princesses are doing great. Okay, this one I'm going to let you try. So just put your answer in the chat room. And if you have a question, just put a question mark. So they tell you this big square is 64. And it's just getting you used to multi-step. Like you might not know how in the world am I going to get the area of this circle, but you just fill in what you need to know. So if you can get the radius of the little circle, you'll be good to go. And I know, Margot, you're going to be watching this later, so. Either one of you see it? So each side, the square area is 64. So each length of the square is 8. So what would the radius be? And then you have to get the area of the circle. Yes. Good. And I'm not doing this to be mean again. I just want you to be used to multi-step questions, because you might get an easy one, but on the harder ones, you're going to have to go through a couple steps to get the answer. So yeah, this is 64. The whole side is 8, so the radius is 4, and 4 squared is 16 pi. Okay, so Sophia, let me go through it slowly for you, okay? So again, I'm just getting you used to, you probably didn't see anything like this in your geometry class. So we have a square where this equals this. The area of the square is 64. So that'll be s squared is 64, or the length times the width. But in a square, they're the same. So then I take the square root of both sides. So the side will be 8. So if this is 8, then this will be 4 for this little radius. And then I can get the area of the circle, because I'll have pi 4 squared, which is 16 pi. Now, see if that helps. Or what part of it are you confused on? They give you the square, and you don't know how you're going to get the area of that circle for sure. But you take, it's like with dominoes. You do one domino, then the next one falls, then the next one falls, until you get your answer. So if we do this is 64, then each side of the square is 8. We divide that in 2. We have to get the radius with any circle, so that'll be 4. Oh, great. Okay, again, it's not to be afraid that you might have to do multi-step. So let's look at the next page. Okay, so we have an area of a circle. So pi r squared is 25 pi. So I know r squared is 25, and the radius can't be negative, so it has to be 5. So I have 5 and 5. They tell me I have to get BC. Now, after we do the triangles, you'll see the triangles bounce off the circles, and so we can't do, but I had to pick one to start today, and I figured the circles would be best. So now, and we'll be doing this next week, you can use the Pythagorean Theorem, which we'll do a lot next week. Again, the good news is you don't have to do a whole geometry book. So we'll have 25 plus 25. So that'll be the square root of 50, which is 5 times 5 times 2 times 5, let's see, no, 25 times 2. So this will be 5, we take out a marriage of 5s, 5 square root of 2, because the 2 stays behind. And once we do the isosceles triangles next week, you'll just say to yourself, oh, x square root of 2. But I don't expect you to know that today. So if that made sense, can you just put C7 in the chat room? Again, it'll make more sense next week after we do the triangles, but lots of times the triangles and the circles will overlap. So just put a C7. We're back in our bingo game. Good, Haley. And like I said, the whole test won't be geometry. Okay, let's try this next one. A circle is in a square. So I draw the square. I put the circle in it. Not so great artistically, but there we go. And so I have to make a connection. The connection will be the diameter of the circle is the side of the square. So I'll just write that down. And they don't say clue, draw a line. I just have to do it. And so I know s squared is 144. So I take the square root of that and I'll get 12. And so the radius is 6 of the circle. And so pi times 6 squared will be 36 pi. So if that makes sense, just say C8. I'm trying to make it at least work for you guys. It's probably good for you to be back in school live now after almost a whole year of virtual. Okay, so Sophia sees it. So like when I took my GRE, I had pancakes on a griddle and I had to draw a line and they didn't say clue, and so Sophia and Haley both see it. Okay, good. Now this one was actually on a test. I freak myself out sometimes when I do them, put them in the packet and then they come up on a test. But they don't, there's not that much they can test on, like there is a ceiling. So even with the geometry, the hardest thing about these circle problems is the multi-step and seeing all the interconnections. So this is a pretty hard one. So this time the square is in the circle. And the area of the circle is pi r squared. So we have to get the radius. So it'll be the square root of 18, which is 2 3s and a 2. So the radius will be 3 square root of 2. And here my connection, and this is why this was the last one on a test. So you can have a great in life and not solve this. But if I draw this, do you see the diameter of the circle is the hypotenuse of the square? So this will be 3 square roots of 2. This will be 3 square roots of 2. So this whole thing will be 6 square roots of 2, which means each side of this has to be 6. That's a hard one to see. But like I said, after we do the triangles next week, basically I just want you to have confidence no matter what geometry figure you see, it makes sense that you do the double steps. So I'll just wait for a C9. I might not get any because this is hard. So if this is still, first I had to get the radius. Then I had to double that to get the diameter. Then I had to sort of work backward. And this will be next week, you'll know that we have 6, 6, 6 square root of 2 because it's an isosceles triangle. But basically, I'm just trying to stretch you so that when you see a circle problem, you're not in a quandary. Maybe I should do it again. So either C9 or a question mark. Yes, I would love to do it, Haley. Okay. This is a hard one. It would be like the last question. So this time we have the square in the circle. Okay, now remember, any circle problem, you have to get the radius. So I have an area, and I know my area formula. So I know that r squared is 18 because I divided both sides by pi. Any circle problem, you have to get the radius. So anyway, that's the square root of 18, and from a radical lesson, that's 9 times 2. So that'll be 3 square root of 2 for 1 radius. And you can have a great life and not solve this one. So if this is 3 square root of 2, and this is 3 square root of 2, the whole thing, when I add them, will be 6 square root of 2. And then what I have to do is get the side of the square. And it'll help next week after we do the triangles. You'll know this is 6. Right now, you probably can't see it, but next week we're going to be doing, on the weekend, we're going to be doing, so you'll have a 6, 6 isosceles triangle. So this will be off your mental fingertips. And I realized not having geometry, having it 2 years ago, and for you, Haley, on top of Algebra 2, I just don't know how you did that. The homework alone would have killed me. Does that sort of help that the answer is 6? It'll get more clear next week after we do the triangles. Sophia, how are you on 9? Oh, you got it. Wow. That's amazing. And how about Sophia? Are you sort of okay? Even if you somewhat see it, that would be good. I love the eureka moments in math. Okay, so Sophia's good. Okay, so we're going to erase all this because we're going to go on to a couple more. Again, I'm just trying to stretch you. You know, we did the foundation of what circles are. Okay, so if we have a wagon that has a wheel of 6 inches, and every time the wagon wheel rolls, do you see it goes 1 circumference? Because if I put a little mark on the tire, it would be here and here and here. So if it goes 100, 2 pi r's, and r is 6, that would be 1200 pi. And that's in inches, but I have to change it in feet. So I'm just going to divide by 12 inches in a foot. So that would just be 100 times 3.14. And most of the time, you don't have to multiply by pi. But here you do, and so the answer would be 314. So more, I'm just conceptually seeing if you get that every time you roll the wheel, you go with circumference. So I'm going to just wait for some C10s, and I'd be happy to go over it again. Again, 2 years without a certain math class, and you can get a little rusty, but I think the best thing is that they don't expect you to do any proofs. So just waiting for C10s or a question mark. Thanks. Okay, so Sophia sees it. Haley sees it. Great. Again, I'm just trying to stretch your mind. So let's try 11. The number of square units in the area of circle O. So the area is going to be pi r squared. And that's equal to the circumference, which is 2 pi r. Assuming that the diameter has to be greater, that's just a 0, sorry there. What's the area of circle O? Well, we know the first thing we have to do is get the radius. So we're going to divide by pi. That'll be r times r is 2r. So that'll be the radius is 2. And so if the radius is 2, pi r squared would just be 4 pi. And we did have that circle in the beginning of the lesson where the circumference equaled the area, which was unique for a certain circle. Okay. So I'll just wait for a C11. I'm just trying to stretch you with all kinds of word problems. And the other thing is next week when we do solid geometry, obviously with the cylinder, the top and the bottom of the cylinders will be circles. So I'm just waiting for C11s. It does sound like bingo when I do this online. Thanks, Sophia. Okay, great. Now we're going to go into something else, which is arcs and sectors. So the whole circle has 360 degrees. And so an arc is just a portion of the circumference. And the sector is like a pizza slice. Now, there's a formula at the bottom of this page, but I don't want to confuse you with another formula. The easiest thing to do, and what we're going to do to show this, is go to a question in the book. So if we could go to 989, number 2. Okay. So here we have a circle. And we have perpendicular lines, so we know that each of these is 90 degrees, right? And our job is to find arc AC. Well, then instead of using that crazy formula and burdening you with yet another formula, what we have to see is what fraction we have. So 90 over 360. We have 1/4 of the circle, and they give us the circumference as 36. So we just have to do 1/4 of 36 is 9, which is answer choice A. Thank you, College Board, for 10 points. So if you see that one, just put C2. And so that's all you have to do is just make the fraction. You multiply times the circumference if it's the arc, and the sector if it's the other thing. And like I said, the good news is these will not be all over the test. They're just going to be, so Haley sees that, so you're just doing the fraction of the whole 360 and then times the circumference. So Sophia and Haley both see it. Let's try, that was pretty easy, but let's try a real hard one. The hardest one, actually. Let's go to 597. Number 20. So here we have a circle. And I know that, and this is the hardest one on a no calculator, I know BC is the arc, and it's 2/5 of the circumference. So that means that X, here I've never used green much, so that X will be 2/5 of the 360 . And it looks like it's about 144 degrees, doesn't it? So if we did see 2, let's see if you see 20. That was a little bit harder. I'm trying to gently take you up a level. And just give you a lot of familiarity with all these circle problems. Okay, so Haley sees 20. I'm just doing 2/5 of the circumference. I mean, this is sort of the reverse. 2/5 of 360 would be 72. 2 times 72 is 144 degrees. Because they only give you the circumference formula, the area formula, and the degrees in a circle and the radians in a circle. Okay, so Sophia saw that hard one too. Great. Okay, so let's go to the pizza problems on the next page. And this is not to make you hungry, but you don't have to know this formula. Just think fraction. Because I like to tell you what you don't have to know. So, in this crazy pizza problem, it's 8 inches across, So we know the radius is 4. So the whole pizza crust, that would be the circumference, is what I'm talking about. So that would be 8 pi, 2 pi r, or pi d. The whole pizza, as far as topping, would be pi r squared, which would be 16 pi. Now, just like in our book problem, we have a 90-degree point. How many 90-degree slices could I make up the whole pizza? It would be 4. How many inches of crust does this one slice have? So it would be 1/4. I don't even have to do the 90 over 360, but I could, of 8 pi. So this crust here would just be 2 pi. So if I did the topping, which is the pizza slice, don't worry that the topping goes onto the crust. I would just have 1/4 of 16 pi, which would be 4 pi. Okay, let's try one more pizza. How many inches of crust would this whole pizza have? Well, the diameter is 12, so it would be 12 pi. The radius here is 6. So how many square inches of topping does this whole pizza have? It would be 36 pi. So 40 goes into 360. I would actually get 9 slices. So how many inches of crust does one slice have? It would be 1/9 of the 12 pi, and they would probably reduce that. And then this next one, how many square inches of topping? It would be 1/9 of 36 pi, which would just be 4 pi. So if you just tell me if you see the pizzas, because it was just in more practice. Okay, so Haley's good with it. It's just, you don't need that big formula. You just need to do the fraction that you need. Thank you, sweetheart. And we'll wait for Sophia. She's way out in Venetia, so it's a little further. So this isn't a brutal lesson, but it's just getting you used. Good, Sophia. Thank you, honey. Okay, so we're going to try a few more of these and then go on to something new. Actually, let's try a book one. I want to go to 460, number 6. This one's pretty hard. And I'll show you how I attacked it. So we have a sector here, COA. And they tell us that this is 100 degrees. And this arc, CDA, is going to be 5 pi. Okay. So we're going to just do a relation. So our mission, make this sort of Christmassy, we have to get arc ABC, which is this guy, and we don't know what that would be. But we do know that the whole circle's 360. And so if we take out that 100, this part would be 260. So we can set up a little relationship. We can do degrees. We're going to do this, a lot of this in the ratio lesson, over, let's call it the arc. And again, I'm just trying to get you ready no matter what you see. So here we have 100 degrees is 5 pi. And we have 260 degrees is, we don't know, we'll call it x. So we're just going to cross multiply here. Then divide by 100. And we'll call it x pi. And so the answer has to be 13 pi. But I just wanted to give you another kind of one. So if you see 6, just put that in there. I see 6. And it's just comparing the degrees to the circumferences. And we had to know that the whole circle was 360. Okay, so Haley's okay with that. Pretty hard one. I think that's pretty hard. And we're going to do a lot with these ratios in a lesson coming up. Because ratios and percents you haven't seen in a while too, like this geometry. And I know Sophia's out there in Phoenicia, so we just have to wait for a leg. Oh, great. Okay, that's great. Okay, so let's try back to the packet. Couple more. So we have a circle, this diameter 12. So right away we know the radius is 6. And we want area, so that'll be 36 pi. We have 6 equal sectors. So again, it's just to get you comfortable with circles. Thank God we don't have to go over all those proofs, right? Okay, we're now going to go on to 2. We have a circle with an area, and so we know we have to get the radius. And they will give you these formulas, but we're trying to give you a review on circles. So with this one, we have the pizza slice, and we want the perimeter of the whole pizza slice. So I'll just do it here. We need this, this, and this. So we need 4 plus 4. And then right here we need 1/8 of 2 pi r, which is 4. And so this will be pi, and so we'll get 8 plus pi for that one. So if you see 1 and 2, just put C1 and 2. This one was tricky because they asked, this would be a harder one. And by now you're pretty comfortable with in the test where the hard ones are. Okay, so Haley sees it. Jim?
Yes.
I might take them through the circle on a coordinate plane and let you do those pick 5 problems at the end of this section, okay?
Just tell me what I still have to do. What are you
Yeah.
worried about time or something?
A little bit. I don't want to.
Got like half hour until 7.
Yeah.
Yeah,
Okay.
whatever.
Okay, great. So now we're doing 3. Not so bad. We're trying to get the area of ABC. So we know that sign means it's 90 degrees. And we did one like this. That means we need 1/4 of pi times 8 squared. So that'll be 1/4 times 64 pi. And so that will just equal 16 pi. Thank you, College Board, for 10 points. That one isn't so bad. So if you see 3, just put that in. The next one is getting into Harvard problem. So you can have a great life. This one would definitely be in the end zone. But I'm just waiting for C3s in the bingo game. Okay, so Haley sees it, great. Oh, good. Now this is about as hard as it gets because they can't do much else but this. So I'm going to go through it slow. So we have arc AB and we know its length. So we're trying to get the area of this sector. So we know always we have to get a radius or we're going to be lost. So we have to figure out 30 over 360 is what fraction. So we can sort of see, I think it's 1/12. So 1/12 of 2 pi r of the whole circumference is 9 pi. That's the hardest part, is just setting it up like that. But I don't have to use that unwieldy formula. I just have to say, what fraction do I have? I have a 12th. I mean, you can have a great life and not solve this one. Like my son, who's an art teacher at Mount Lebanon, math wasn't his thing. So we only had to do, this was his last hard math push, honestly. He only had to take 6 credits of math at Penn State. Okay, so now we have to get the radius. We have to get this r. So 2 over 12 is 1/6. So we can divide both sides by pi. If 1/6 r is 9, then we just multiply both sides by 6. And our radius is, voila, 54. Thank you, College Board, for 10 points. Now we have to get the area of this sector, like the pizza slice. So we're just going to do 1/12 of pi r squared. We already have the r. Okay. And now we just have to get a number out of that. Well, let's see. This is 6 times 2. So, I guess I'll just multiply it out. Of course, you'd have a calculator on your test. Divided by 12. I keep the pies, remember. So it would be A. Now, I don't expect you to actually understand it all, but if you almost get it, so could you just say almost or yes? Because I understand this would be, I don't even think you get one this hard. But anybody aspiring to a really high score, I want to sort of stretch them. So I'm just going to wait for an almost or yes. It's just getting the radius first. So on test day, on October 2nd, my job is to pray, you feel angel wings. And if you get a circle problem, just say, I got to get the radius somehow. Because if you get the radius out of the circumference, which we got 54, we could put it back in and get the area. Okay, so Haley has almost. So that's good, hon. Because, I mean, I don't expect you would get this one this hard. Okay, great. I'm going to have Jim take you through these later. So right now, I want to go to all the way. We're going to go to degree radian conversion. So if you would jump to that page, I know we skipped a lot. And I don't know that you have to go over every one of those, Jim, but...
What, the 10 problems to become a circle expert?
I don't
I'll probably
know.
have them pick 5.
But,
Maybe.
yeah, but I don't know even. Okay, so is everybody with me on this page? So remember we said 360 degrees going all the way around the circle, and that equals 2 pi. So basically, the whole circle will be 2 pi. Half the circle will just be pi. So, they give you this. So all we have to do, there's no negatives. We just have to figure out how to convert. So I like to do, since 2 pi is 360, I like to do pi is 180. Because going around half the circle would be 180. Okay, so if we convert 40 degrees, how many have you guys seen? Let me just ask you, if you've seen this conversion, just let me know, of radians to degrees and vice versa. I'm just going to wait a second for you to see if you see this. Have you ever seen this? Oh, so Haley's seen it. Good. Okay, what about you, Sophia? I'll wait, hon. And you won't get a real difficult one either. Oh, Sophia's seen it too. So let me do this and we'll try a couple in the book. So we don't have to worry about negative ones. So if we have 40 degrees, I just like to put 180 degrees is pi. And then I just reduce it, and I'll get 2/9 pi radians. The other way, I have pi over 5, and pi is 180. So I'll just go 5 into 180 is 336 degrees. So we're going to try a couple book ones. We thought they were going to make them really, really hard, but let's try some in the book so you can see about how much what they're going to pretty much ask you. So the first one I want to try is 1135, number 34. So maybe that would be a pretty hard one, I don't know. This one is pretty hard, actually, because it's a calculator one, so that's not so bad. So I'm going to do this two ways. So we know that the central angle AOB has an arc of 5 pi over 4, and we want to get the degrees. So we just have to make this conversion. So one way is to get the degrees. So that would be, remember I said I like to do pi 180. Pi's cancel. 4 goes into 180, 45. 5 times 45 would be 225. And then I put that over 360 because I want what fraction of the whole thing it is, and it would be 0.625. Now there's another way I could do this one, so I'm going to do this in blue. So I could have said, what fraction of the whole circle is it? And you notice this is in the hard zone, so you can have a great life and not solve this. So we have 5 pi over 4 all over 2 pi, because our whole circle is 2 pi. But remember, when if I divide 5/4 by 2, I have to flip the second number. This might be easier. So I'm going to do 5 pi over 4 divided by 2 pi, which is times 1/2 pi. And the pi's will cancel, and I will get 5/8, which equals 0.625. And I could also put that into the grid in as 5/8. So you could either, if you like to work in degrees, you could make the shift, or you could just say the whole circle is 2 pi. What fraction of that is it? And you could just divide this out. And so you can sort of pick your weapon. So let me see if you girls see 34. And you could pick either changing to degrees or just putting the whole thing over 2 pi. We're going to just try a couple more. That was a hard one. I didn't mean to pick a hard one first. Okay, so Haley sees it both ways. That's good. Oh, and Sophia's good. Yay. Okay, let's try another one in the book. Okay. So this one, we're going to go to the hardest one, but not to worry. Page 864, number 20. So I'll let you turn there. See, they don't, I mean, this is their hardest one. So we know that this length is pi over 3. So again, I could do it two ways. Let's change it to degrees if you're more comfortable with that. So pi is 180. So it'll be 60 degrees for this degree measure over the whole circle. For a hardest one, not so bad. It's just 1/6. Or they would take 0.166 or 0.167. The other way would be, what if we do pi over 3 all over 2 pi, because 2 pi is the whole circle. And when we divide numbers, this would be pi over 3 divided by 1 over 2 pi. So I have to flip the fraction. Let's see, pi over 3 times 2 pi over 1. No, it would just be times 1/2. What am I? I'm dividing, sorry, I had too much math. Divided by 2 pi is pi over 3 times 1/2. And I would just get 1/6 pi that way. And so I could say 1/6, 4.116, or 166, or 167. So if you see 20, which is a hard one, I know we're good. Oh, so you both saw it. Yay. Okay, so I think we conquered that. They're not going to give you real hard ones. They might say, I've seen ones like that. 7,400 degrees is what times pi? Find A. And so if 360 is, or 720, sorry. (360) times 360 plus 360. We just went around the circle 2 times, so it would be 4 pi. Now, the next good news is we can skip the whole unit circle. So we can skip, because it's not on the test. This part we don't have to do. We don't have to do the unit circle, so it might make you feel really good just to cross this off. We don't have to do any of this stuff. We can have a great life and not worry about it. But the thing that's on the test that I don't think is necessarily fair This we don't have to do. Like I said, we were over preparing everybody. We have to go to this last page. And I want to cover this, and then Jim can give you maybe a little more practice with circles. Okay, so the circle on the coordinate plane, for some reason, this has been on every test. And I don't know why, because they don't give you the formula. So half of America would say, yikes. So here's the formula. We're going to do a number of these because we're adjusting to what's really on the test. Because I looked at March, I looked at May, and I'm going to look at your October test. By the way, for $18, you can see your whole test if you sign up for that. And so Sophia, I don't know if you took the practice test 7. Haley, we're taking it on Saturday, test 7 on 692 at the rec center. So you can either take it at home or mail it to us. Sophia, I think your dad said you were going to do it on Sunday, maybe this past Sunday, and because you're going to the Steeler game. Her dad's singing the so Haley, her dad's singing the Star Spangled Banner. I've never known anybody who's done that, so I'm pretty impressed. Okay, so this is the formula, and HK is the center. So let's look at this one. The equation for a circle with center 4, 3. So it's 8x, this squared should be outside. So plus, there's a little tricky thing about this. So that means the center of the circle is 4, 3. And this is the r squared. So the radius you can see is just 3. So this is the formula that they don't give you, and I don't want you to be caught off guard because there hasn't been a test they don't put this on, which isn't fair. Okay, so we're going to try, let's try one here. And this is what's tricky about this. Since it's x plus 2, it's going to be x minus a minus 2. Do you see that? So the center of this crazy circle will be minus 2, 5 with a radius of 2. And you probably had this in geometry and they probably didn't cover it much. So we're going to go minus 2 over and 5 up. And then the circle has a radius of 2 in every direction. So we're just going to go like that. And that would be our circle. But this is the hard thing to notice. We're going to do a number of book ones because it is on every test. And so, Margot, if you're seeing this later, greetings. Okay, so I hope that's okay. Let's go to the next page. Okay, we're going to try number 1, and then we're going to try a whole lot of book problems and a couple of colored ones at the end. So what is the equation of a circle? So its center is 3 minus 2, and the radius is 5. Well, I know it. If I write it ahead of time, it's going to be x minus 3 squared plus y minus a minus 2 squared. I have to square this radius. So that'll be x minus 3 squared sorry. So that has to be C. So just tell me if you see 1. Oh, good, Haley. So I guess you had this somewhere. I don't even remember having it in geometry, actually, myself. But because they put it on every test, I want to practice it. So we'll wait for the lag way out there in Venetia. Oh, and Sophia sees it too. Okay, so let's try this one. What's the equation of a circle? Okay, so the center, so we're going to do x minus a minus 2 is the square root of 10 squared. So that'll cancel, and we'll have x plus 2 squared plus y minus 4 squared is 10. And so that one will also be a C. Okay, let's look at this one and we'll try some book problems. This is a little different. So if we have a circle with endpoints of 8, 1, somewhere here, and minus 4, 10, all we have to do is average the x's and average the y's to get the center. So we're just going to do minus 4 plus 8 over 2. So that'll just be 2 for the x value. And then we average the y's. And that's 5.5. So this one would be 2, 5.5. That's just to get the center if they did something crazy like that. And our last one before we try some in the books. So we have a circle that goes through the origin. Do you see that? Because if there's no thing there, it's going through the origin, and the radius is 5. And we have a point 3 over 4 up. And next week, or this weekend, when we dive into triangles, you're going to put at your mental fingertips, this is a 3, 4, 5 triangle. That's going to be very much embedded in your brain after the lesson, because they like to use multiples of those. So we have a line that's tangent. Remember we did this. Tangent just means touching. So we're trying to get the equation of this line. Well, we know from a review, perpendicular lines are the negative reciprocal. And so this line going up this way, rise over run, would be 4/3. So we need the negative reciprocal, which would be a negative 3/4 for this line. And the only one with a negative 3/4 is A. Okay. And so let's just do a few of those. We're not going to do the colored problems today, but I want to do some of these book ones with the circle thing. So the first one I really want to do is pretty easy. I'd like you to do 337, number 11. Wait a minute. I don't know if I have the right page there. Hold on. Wait a second, girls. So the first one I want to do, I'll find it. Oh, I apologize. It's 336, number 11. And I'd like you to just put this answer in the chat room. So they give us the center, and they give us the radius, and we have to find the equation. And I'll just wait for you to try it. So just take a stab at the right answer. And Jim's going to give you a little break in just a couple minutes. So do either one of you have an answer that seems good? Haley, good job. It is A. And that was a number 11, but I still want to try a couple harder ones. Let's see if Sophia sees it. She has more of a leg where she is. Great job. So that wasn't too bad. So, Sophia, do you see that it's A? Again, I wouldn't drill on this so much, except it's been on every test. So, Sophia, are you still with us? Well, Haley, let's try another one. And after these couple, I'm going to give you guys a break. Because restroom and everything else. So if we could try 593, number 9. Because I haven't even given you a restroom break or anything, but we'll give it to you after this. And I apologize. So let's look at this one together. We have x minus 6 squared plus y plus 5 squared is 16. All right, so we have our circle, and we know that if I draw it this way, 10 minus 5 is a point on the circle. And my job is to see let me see if I can draw this. Well, should draw, that's the diameter, so I'm drawing this a little weird. So if that's 10 minus 5, we're trying to get this number. Okay, so looking at this circle, we can see the center is 6 minus 5, and the radius is 4, because this is r squared. So if I put 6 minus 5 is the center right here, and this little value, the radius is 4. It makes sense that that would be negative 10 minus 5. Then going 4 over this way, that would be 2 minus 5. Does that make sense, Haley, that the answer would be A? I think Sophia probably took a wanted break. Do you see that this one, pretty hard, but it's A? Because when I sketch the circle, I can sort of see the other part of the diameter has to be 2 minus 5. Or maybe Sophia's parents had dinner. Okay, great, sweetheart. Let's do 2 more, and then we'll call it a day. Let's go to, I'm just doing this because they're on every test. I promise you, you'll see one of these. 744, number 29. So really hard one, next to the end. Okay, sweetheart. I just want to do so we have x plus 3. Okay, I'm going to sketch my circle. So I know the center is minus 3, 1. And I know my radius is 5. I don't trust myself without the picture. So I'm going to go minus 3, 1. And then the radius is 5. So this is minus 3, 1. So I'm going to go 5 degrees in this way, 5 degrees, or 5 units in this way. So this point should be 2, because I'm going over 5, 2, 1. And this point over here should be negative 8, 1. And again, it's just the same formula, and I think the easiest thing is to draw the picture. So we're trying to find, this is a really hard one, which one does not lie in the interior? Well, minus 7, 3 would be okay, right? Minus 3, 1 is the center. 0, 0 is okay, it's in the circle. But do you see that 3, 2 would be way outside the circle here. So that has to be the answer. So I'll just wait to see if that makes sense to you. Again, I just want you familiar with this. We'll just do one more and then I'll give you a break. So if you just say C29, Haley, and Margot's you're gonna be seeing this a little bit later. And we're gonna do one more. Oh, thanks, Haley. Again, I just want to break down a couple of hard ones in case that's what they give you. Okay, so on I don't know how you would be able to, I don't think I ever had this formula the whole time I was in school. Okay, so our last one we're going to do is I don't know what one we just did. Let's try 1010 number 29. I know I'm doing a lot of the hard ones. This is one right at the end. And this involves a little bit of completing the square. So they wouldn't expect the average junior to get this. It's all going to pay off in a couple of days, sweetheart. Okay, I'm sorry I'm pushing you so much. Okay, what if they gave us this brutal one? So what I have to do here is I have to complete this square. So I'm dividing this by 2. So I'll really have x plus 10 squared for this part, which will be x squared plus 10x plus 10x plus 100. And then this part would be y plus divided by 2, 8. And so if I add 100 to this side, I have to add 100 to this side. I'm just dividing this by 2, so then I'll have y squared minus a minus, oh, this will be x minus, what was I, wait a minute, no, I'm good, I'd say I'm good. Yeah, it will be x plus 10, and this will be divided by 2, so it'll be y plus 4, so I'll get y squared plus 8x plus 16, add this all on here. I guess I don't even need this now, I'm just realizing it. Wait, hold on. If I had to get the radius, hold on, look at this. So I would have 16 and 10. Oh no, I would have 64, sorry. I'm getting tired from all this. Okay, so we have 164 minus 20. That makes sense. So it would be 144. So if we had to get our radius, it would be 12. But we don't have to get it. We just have to do x minus a minus 10 squared plus y minus a minus 16 squared. So our center Oh, that's be 8. Sorry. So our center would be minus 10 and a negative 8, which would be answer choice B. And sometimes they ask you to do the radius, so that's why I wanted to. If you add something to this side, you have to add it to the other side. I just wanted to do one like that in case the radius was 12. Oh, that's okay, Sophia. We figured something like that had to happen. We're about to give you a break. So, Haley, if you see 29, just let me know. And then I'm going to give you both a break. It's okay, Sophia. I figured something happened. Also, you guys need a restroom break and to get a snack. So, Haley, do you see this 29? And then, Jim, I'm going to just have them come back.
Yeah, give him a break.
Okay, good. Back at, how about,
7:17, I guess, so.
So how about back at 7:25?
Yeah, that's fine.
So just go get a snack, use the restroom. I'm sorry we went real long on math. Okay. Ready?
He's a little bigger. You got an answer to the road?
No, we're in their garden.
No, we're outside in the back, but I'm just taking this to the car. So I have one. Mother already has one. So you want to do this in that car?
Haley's back. Okay, so it is time to start going back at this, looking at just a little bit more math. Mrs. Hessler left some math. I'm not going to make you do it though, because I think she made you do a ridiculous amount of math questions already. Sophia's back. Yeah, I'm just going to run through these 10 problems to become a circle expert. You know, normally she would have you try these and then I'd go over them, but I think that you've done enough of them. We can just run through these pretty quickly and then start the English, I think. So, let's look at the first figure. And Margot may be watching this later, so that's cool too. So here's our figure. It says, in the figure above, AB, CD is a rectangle, and it looks like my line segment lines got moved over, but don't worry. So line segment BC is twice the length of AB, and AB and CD are the diameters of this semicircle. Okay, so we just have to do some basic algebra to figure out that this is 12. So if AB is half the length of that side, then it would be double. Okay, and then so quick, normally when you're trying to do a figure like this, you would subtract the shaded area to try to come up with, or you would subtract an area to come up with the shaded region. But do I really, here's my question to you, is this a waste of time? Do I need to calculate the area of this semicircle and then add it over here in order to figure out what this figure is? It looks like they just they took the same semicircle out of it. So I have a circle here. It makes no sense to add it back to the figure. So the actual shaded area will just be 72. Just 6 times 12. So we don't really need to move that over or subtract it, then add it back. That wouldn't really help. So just be aware that some things they're trying to like make time wasting tactics, like this one for this next figure. So this kind of looks like a flower, and it says this circle with radius 12, the big circle, is divided into 4 congruent sectors, and there are semicircles. So I have 4 semicircles, which means that I have 2 circles. 4 semicircles is 2 circles. So 2 circles with a radius of 6. So the way I'm going to approach this question, I'm going to find the big area, the big circle, and I'm just going to subtract the 2 semicircles. So the big circle, if this were all shaded, would be pi r squared. So 12 would be our radius. So 144 pi would be the big circle minus, now I'm going to subtract 2 semicircles. So each one of these circles has a radius of 6. So I know that each one is pi r squared, or 36 pi. But I have 2 of them. I have 2 semicircles, or 4 semicircles, 2 full circles, 2 little circles. So that'll be 144 pi minus 72 pi, or 72 pi. So that's this one. This one is C. So it's still not too hard. Maybe they're getting a little harder. Okay. A line. Okay, these are diameters. AC is a diameter. DB is a diameter. And we have a circle O. So this value is 160 degrees. And they want to know the length of arc AB. I'll just draw it in. They want to know how many times is this arc, how many times is arc CB, or BC, however, how many times, I'll draw this in with black. Comparing these two, how much bigger is arc AB? That's all they really want us to know. So there's a pretty easy way to figure this out. I'm just going to use our same formula that we've been using from the part-whole relationships. So I can put this angle over 360 degrees to figure out how long AC is, or AB is. So let's just do that. Let's just say that arc AB should be 160 degrees over 360 because there's 360 degrees in a whole circle, but I don't have a whole circle. So if I multiplied 2 pi r, and I don't know what my radius is, they don't really tell me. This would give me the length. So I'm just going to reduce 160 over 360. And this, we got to figure out what this value is here. What's this length? Well, it's pretty easy because every straight line on the SAT is 180 degrees. So that's a straight line. So I know if that's 160 degrees, 20 degrees, just taking the 180 degrees, subtracting the 160, this has to be 20 degrees. So I know my tiny arc is going to be this. It's going to be 20 over 360 times 2 pi r times our circumference. So really I'm just comparing, I'm just going to reduce these. Let's just reduce both of these and see what the values are. So 160 over 360, that reduces to 8 over 18 times 2 pi r. And then this one will be 20 over 360 reduces to 118, 1 over 18 times 2 pi r. So how much bigger is this longer line segment than this shorter one? It appears to be exactly 8 times bigger, which is answer choice A. So all I did was compare the big arc to the little arc. I just put the value of my angle over 360 to figure out the length, what the degrees would be. So that one's 8 times bigger. Not too hard, and it's pretty easy to see. We even really, if you're savvy with this, you should be able to go right from this 20, multiply it by 8, or divide 160 by 8, probably go that way. If you were really clever, you realize, well, since this is the same circle, these angles are going to be in the same ratio to one another. So all I have to do is figure out what did I divide 160 by to get 20. So you can figure it that way. That would really save a step maybe. All right, here's our next one. So here's a rectangle ABCD, and I've got quarter circles now. Each one is a radius of 1. So that's 1, that's 1, that's 1. So the whole, I'm going to subtract the circles from the rectangle. So the whole area of the rectangle would just be 2 times 1, or 2. And so now I'm going to subtract 1/2 circle. I said that my radius was 1. So if I have half of a circle, pi 1 squared would just be pi over 2. So 2 minus pi over 2 is the correct answer for this one. That would just give me the shaded portion because I'm taking the big rectangle and then I'm subtracting 1/2 circle, this part, to get the last little gap there, the little black part there that's shaded in. All right, here's the next one. Number 5. Here's a tricky one. So it says in the figure above, if you have any questions, please put them in the chat room. I'll try to do my best to explain this. but I know you've already done a lot of math, so I'm just trying to get through this just so we can do some English. All right, so in the figure above, the diameters of 5 dotted semicircles are equal and lie on line segment AB that has a length of 20, so this whole thing is 20 long. So that's all 20. I know that I have 5 dotted semicircles that are taking up the entire length of line segment AB. So I have, there's actually a couple ways we could do this one, but I'm going to try it this way. So this right here is half of a circle, and this is the other half of that same circle. So that will be one circumference. So even though I'm drawing, the rest of the circle out this way, it would be the exact same measurement as the similar circle here. Okay, so that's one. That's one circle to here. Here's another circle from this point. That's our other circle. So that's 2 circles and a half. So I have 5 halves total times, let's figure out the circumference of one circle. Well, if I'm dividing this line segment AB by 5, 20 divided by 5 is 4. So I know that each diameter, or each one of these is a length of 4. That's a length of 4. I know it's kind of hard to see, but so because that's 4, I know that's our diameter. So pi d is the circumference, or 2 pi r, however you want to think about it. So 4 pi would be the circumference of one circle, but I have 5 half circles. I have 2.5 circles. So if I divide this by 2, there's 2 left, and the answer should be 10 pi. So that's how you do that one. You just figure out how many circles total we have, and then figure out the circumference of one of them, and not too bad. This next one's not too hard, so they will test you on this. So this circle has a radius of 6, so that's 6, and they want to know the length of AB. So I know that this is 90 degrees, so I know that I can put 90 over 360 to get the entire circle, and then all I have to do is multiply by the circumference. The circumference of this is 2 pi r, or 12 pi. So 90 over 360 is just 1/4. And then I'm just going to take 1/4 of 12 pi. That's our circumference. Sorry, I keep writing 11 instead of 12. 12 pi. All right, so our answer should be the 3 pi, which is right here. So can you figure out the length of sector AB? All you have to do is put part over whole. In this case, it's 90 over 360, or 1/4. And then you're just going to multiply by pi times the diameter, which is this, 12 pi. Here's 7. So every straight line on the SAT is 180. So I immediately know if there's 50 here, that would mean the other remaining 130 goes here. And we're going to do this in the triangle lesson, but every triangle, the internal angles of every triangle add up to 180. So here I already have 130. So we just got to figure out what's left. It is 50, meaning that each one of these is 25. That's 25. That's kind of hard to see this pen. So because that's 25, this looks like a 90-degree angle to me, right there. So I will just take 90 minus the 25 in order to get 65, which is answer choice C for this one. Next one, this was pretty easy. So this circle has a radius of 1. circle A has a radius of 2, and circle C has a radius of 3. So we just have to add up. We're trying to make this triangle ABC. So this is pretty easy. So it's 3 plus 5 plus 4, or 12. For this one would be a grid, I guess. 12. This one, ABCD, is a square, and A and C are centers of the circle. If AB is 4, what is the total area of this shaded region? So here I have 2 3/4 circles. So I have 2 of them. I know they're both 3/4 big because I can see that. This is the 1/4 of the circle. This is the 3/4 of the circle. So let's figure out if AB is 4, that's our radius. So pi r squared is our area. So this would be the area of one circle, 16 pi. But we don't have one circle. We have 2 3/4 circles. All right, so now I just have to multiply this through, and you should get 24 pi, which was C. And here's the last one. A fan is created by gluing paper sticks to 7 sticks. A fan is created by gluing paper to 7 sticks that are joined at one point. The figures above show the fan nearly closed at the left and fully open at the far right. When opened, the fan forms a semicircle. So here's the semicircle. And here is when it looks like it's 5/6 opened. So that's 5/6 open. This is the full semicircle. Okay, so they want to know what is the angle of one of these now that it's been opened. So the easiest way for me to solve this question is I'm going to solve for one of these angles on a fully opened one, and then I'm just going to take 5/6 of this value, if that makes sense. So in order to calculate it first, we have to figure out how many degrees this angle would be. So let's figure out how many times we've divided our semicircle into sectors. 1, 2, 3, 4, 5, 6. It looks like we have 6 sectors. 1, 2, 3, 4, 5, 6. Okay, so in order to figure out what one of these angles is, I'm going to divide an entire circle. Actually, I'm going to divide half the circle because I only have half a circle. So 360 degrees is an entire circle, but I only have half of the circle, which I know is 180. So I'm just going to divide 180 divided by 6 in order to figure out the number of degrees for a fully opened one. And that would be 30. Okay, so now I know this value. Now I know that one of these is 30 degrees. So now I just need 5/6 of 30. I need to figure out what this would be, which is not entirely opened. It's only 5/6 opened. So I'm just going to take 5/6 times 30, which is 25. And that was a pretty hard one, but you would just grid it to 25, and that's all. That's it. We're done with math. So yeah, thanks for sticking in for this extra little bit of math. I'm sorry that I went over, but it's fine. We're going to switch on to English now. So we are doing the science passage. Find the packet that looks like this. Just going to hold it up for a second so you can see it. Science passage. I'm going to find it here. Okay, the science passage. So these are on every SAT in the reading section. You will either get 2 science passages or you'll get 1 and 1 pair of science passages on a similar topic. So don't be intimidated if science is not your strong point. If you dislike chemistry, if you dislike biology, don't worry. It's really just reading comprehension that they're testing you on, which is more the skills that you learn in English class than, say, a science class. I would say that the text complexity isn't super high. It's not super scientific. Any kind of jargon will be well defined for you. So they're not really so much testing your science abilities. They're testing your comprehension. Can you understand this passage that's presented to you? Can you answer some questions about it? You're not going to be performing as an experiment. You're not going to be creating a hypothesis or doing any actual science. That's all I'm trying to say. These passages, they tend to read like a Popular Science, if you've ever seen that magazine, or a Scientific American, Discover magazine. It's science for the lay person, typically. It doesn't read like a chemistry textbook. These don't read like physics textbooks. They read like something you'd pick up at a supermarket that just happens to be scientific in nature, right? But it's science for everybody. It's not written for scientists. That's what I'm trying to say. These passages are written for everyday people, and you can answer some questions about them. So don't be intimidated if science classes aren't your favorite type of classes, because really you just need some skills that you maybe learn in any English class, or though it's scientific in nature, really they're just testing your reading comprehension. Could you remember the passage? Could you answer some questions? To what extent did you understand the thing? So here we have a science passage, and this one's about a fish, and then we have some questions that go along with it. I'm going to give you guys some time. Just read this quick science passage. Read this science passage here. It's not too advanced. It's not mitosis and meiosis. They talk about the discovery of a fish, and it's science for everybody. It definitely reads like science for everybody. So take a shot at this one. Read the passage, and then see if you can answer the 10 questions that go along with it. I'll give you guys some time to do it. Sophie and Haley, you just put done or finished in the chat room whenever you've done or finished these. Oh. Oh, I'm sorry, Haley. Yeah, I'll leave it up on the screen. I'll try to keep it so that you can read the whole thing. That's pretty crazy. I'm gonna apologize that happened. We gotta worry about our quality control here. I'll keep it up for plenty of time. I'm sorry. Yeah, you can read it off this screen. I'll scroll down so you can still read it all. I apologize. Yeah, I know my head is partially blocking a paragraph, Haley. I'll move it in a second for you. Haley's finished. Yeah, sorry about that missing page, Haley. I feel bad about that. But hopefully you can sort of read it off the screen here. Just give Sophie another minute. Oh, you're finished? Okay, great. Let's go over these then. All right, so this first one looks like a main idea question to me. If you see the words primary purpose, you should probably think main idea versus a detail. So they are testing you on main ideas. All right, so big picture, main idea. Primary purpose of this passage is to what? Are we speculating about unidentified sea creatures? Are we discussing museum curation? Am I primarily relating a notable discovery, or am I primarily studying deep sea fish, plural? Let's start with answer choice A. I don't think that there are any unidentified sea creatures in this passage. We're talking about the coelacanth, so we've identified everything. I don't think it's A. We've identified all the sea creatures that we're interested in talking about. We're talking about coelacanths. So answer choice B is more of a detail. That's what we're looking at here. So the fact that Marjorie Courtney Latimer was a curator of this museum, that's just a detail. That's not what this passage is about. Just a detail. So detail versus main idea, that would be a detail. That is not the primary purpose of this passage, just a detail. Really, it's relating this notable discovery. We're not studying deep sea fish, plural, primarily. Mostly, half of this whole passage is just about the discovery itself. I think up until this point, maybe, we're just learning about the discovery, and then they talk a little bit more about the specific characteristics of the fish. So it's mostly about the discovery. Here's a vocab question. And I'll pull this up on the screen so you can see it too, Haley. So in line 26, they use the word upset, and they ask us, what does this most nearly mean? I'm going to read the sentence as written, and then we can decide which word would mean the same thing. All right, so I'm looking at this word upset. So clearly upset can mean different things. I upset your feelings. I angered you in some way, but let's see what it means in the context of this sentence. I'm going to read the words back in the sentence. I'm going to try defeat. I'm just going to read the words in. The discovery of a living coelacanth would defeat the established order of the scientific world, as the creatures were thought to have gone extinct millions of years before. So that makes no sense. Clearly, upset does not mean defeat. This would be in the sense of an upset, right? His victory was an upset. The team that you thought was going to win didn't win. That it's an upset in that sense. But that doesn't make any sense in the context of this paragraph. I'm just telling you that's how they write these questions. They just look up different definitions for this word upset. And yeah, it could mean that I upset your feelings, but not in this sentence. Let's try perturb. Okay, the discovering of a living coelacanth would perturb the established order of the scientific world. So perturb means the same thing as answer choice D. It means irritate. I'm going to read irritate in there. Perturb, if I perturbed you, I irritated you. Okay. The discovery of a living coelacanth would irritate the established order of the scientific world. Neither of those make sense. Let's try disturb. It had better work. So perhaps to upset something could disturb it. Like he upset the table on his way out of the room and knocked something over. Perhaps disturb work. Let's try disturb. All right, so the discovery of a living coelacanth would disturb the established order of the scientific world, as the creatures were thought to have gone extinct millions of years before. And that makes perfect sense. So to upset can mean to disturb the balance, upset the balance. Let's look at 3. As used in line 56, the word distinctive most nearly means what? So here's another vocab question. I will highlight this word for Haley's benefit so she can see where it is in the passage. Line 56, right here. All right, so I'll read the sentence as written. It says, dissection of coelacanths has yielded knowledge of many distinctive features. Hinged brain cases, lobed fins, hollow spines filled with oil, distinctive tail fins, and oil-filled bodies. So what's distinctive about a coelacanth? And this, you might be tempted into picking answer choice B because you might think, well, these are certainly unusual fish, right? The only problem is distinctive never means unusual. Whatever answer choice we choose cannot violate the dictionary definition of this word. And distinctive never means the same thing as unusual. It just doesn't. So even though you may think this fish is unusual, the word distinctive does not mean unusual. That's the problem here. So even if it makes sense, I know I recommend reading the words back in the sentence, but it has to work in the context of the sentence, and it also cannot violate the word's own dictionary definition. Really, when we're talking about the distinctive features of this fish, we're just talking about what distinguishes this fish. How can we distinguish this fish from, say, a tuna, some other fish? What are its distinctive characteristics, its distinguishing features? Which would be characteristic. Its characteristics, its characteristic features. I'm going to read this one back in the sentence. Answer choice D should make sense, and it also does mean distinctive. I'm going to try it. All right. Dissection of coelacanths has yielded knowledge of many characteristic features. Hinged brain cases, lobe fins, hollow spines filled with oil, etc. So that makes perfect sense. These are the distinguishing characteristics, the distinctive aspects of this fish. This is how I can tell this fish apart from a different one. The passage indicates that coelacanths are they scarce, isolated, agile, or intelligent. Interesting. So I'm pretty sure the passage does not mention their intelligence. I don't think it mentions their agility, their ability to swim well or whatever. I think we have it down to answer choice A or B. They are either scarce or isolated according to the passage. And this one's actually kind of a tricky question because you may be tempted to pick answer choice A, but we actually we know nothing of the scarcity of this fish. We know it was difficult for them to locate one, but that could be for other reasons. That could be the habitat of the fish. When was the last time you were 700 meters below the ocean's surface? It's maybe just a hard place for most people to get to. There may be many of these fish down there. We really don't know, and the passage actually does not indicate how many of these that there are in the world. So we can't go with answer choice A. We know nothing of their scarcity, really. We know it was hard for them to find one, but that might have more to do with their habitat. We know that they are isolated at those depths, though. They can't go anywhere else or they die. They are isolated there. And now I have to find the evidence from the passage. And the best evidence for the answer for 4 is answer choice C for 5. I'm going to read these words from the passage, and this should be good evidence that these fish are isolated at these depths. I'm going to try to read these lines, 62 through 65. Unfortunately, this strong adaptation to the ocean depths, where few creatures can survive, may be what causes their abrupt deaths at the surface. No coelacanth has ever been captured alive. So they are isolated at that depth. 6. The passage indicates that coelacanths are similar to human beings in what way? Well, they compared them. To find the part of the passage where this is. Right here. I'm just going to read it. Like human beings, coelacanths practice tetrapod movement. Just as we move our arms in unison with our legs as we walk, coelacanth fins function likewise in their propulsion. So they've compared the coelacanth to human beings in relation to their locomotion, how the human being gets around. I guess if you were to watch this fish swimming around with its arm-like fins, it would be similar to if you watch a person walking with our arms move as we walk because we have tetrapod movement. So tetra means four, so 4 arms, or 4 arm-like fins in this case, or for a human being, that would be the legs and the arms. So that's tetrapod. So they're similar in locomotion, and now the evidence, I found the evidence, I read it for you, it's right here. 72 through 73, those were the lines I just read. The primary purpose of paragraph 5 is to do what? So I'm just going to count the paragraphs. 1, 2, 3, 4. This is paragraph 5. So what is the purpose of this paragraph? Well, every single sentence in this paragraph seems to just explain the physical nature of the coelacanth. What makes a coelacanth a coelacanth? It's describing the body of the fish. It's describing their offspring. It describes how they get around, how they travel underwater. Every single let's go through some answer choices. See if we can eliminate some first. So, are we discussing coelacanth discovery in that paragraph? No. The discovery ends like right about here. Now we're no longer discovering this fish. Now we're just talking about it. So this whole first half of the entire passage is just the discovery of the fish. So that's incorrect. We've already discovered the fish by that paragraph. Does this paragraph discuss coelacanth evolution? Does paragraph 5 discuss coelacanth evolution? No, it's actually the next paragraph. It's paragraph 6 that talks about the fish's evolution or lack thereof. So it's not that answer choice. That's a little too soon. It doesn't reiterate the importance of a finding, really just examines coelacanth physiology. So physiology, this ology just means study of, and it's study of the body. Physiology is study of the body. And in this case, it's study of the coelacanth body. What makes a coelacanth a coelacanth? So the limb-like fins, the hollow body filled with oil, etc. Everything that makes a coelacanth is in that paragraph. Just explains their physiology, their makeup, physical makeup. Number 9 says the similarity. I'm going to have to read these lines. These lines serve a function. I'm going to read these lines. The similarity of coelacanth fins to mammalian limbs influenced scientists to initially label the coelacanth as the missing link between the evolution of land animals and fish. So we're just analyzing this statement. What does this statement mainly do? That is a theory. It's not an anecdote. An anecdote would be some amusing personal story, something that actually happened to you. I ran into my friend Kim the other day, and you tell me about this story of this interaction. It's not an anecdote. It's not so much an opinion as it is a theory. We have a word for scientific opinions. We call them theories, right? So it's not the opinion of evolution. So we have a theory. It's not the counterclaim. The counterclaim is this. I'm just going to circle the counterclaim. Here's the counterclaim. This is no longer believed to be the case. It does not appear that coelacanth has ever left this ocean depths. But we're talking about this part. We're talking about the part that comes before the counterclaim, which is just a theory. It's not the counterclaim. So that one was B. And in the context of Darwin's theory, coelacanths can be viewed as what? So I'm just going to read lines 84 through 85. Charles Darwin had postulated the concept of living fossils. He believed that without the pressure to adapt, creatures could continue to exist in their ancient forms. So for this one, I'm going to look at the answer choices. They can continue to exist in their ancient forms. Interesting. So let's look at answer choice A. If coelacanths are variable, that would mean that one is very big. Trying to draw a fish. Oh, that was a bad fish. See if I can do this again. Okay. So if they're variable, one's very small or very big, I guess, and the other one's maybe this big. So that would be variable. Just like in math, they vary to a great degree. If they're variable, perhaps they're highly different from one another. They're they vary in color or size, something. There's no indication of the passage that they're variable. It's just not in there. What about mutable? Are they mutable? This is kind of a tricky word, but there is a root to this word, mutable. This is an adjective. I want maybe the verb. Do either of you know what verb this goes with? This is an adjective. Mutable is an adjective. So I can use it to describe a noun. Adjectives modify nouns. But I'm looking for a verb. What is the root word of this entire word? It's mutate. Mutable means that they mutate frequently, and we know that's not the case. According to the passage, they exist pretty much in their ancient forms. They have hardly changed for, see how long, for 360 million years ago. These fish have hardly changed at all. They predate dinosaurs. So I don't think that they are mutable. I think that they don't mutate frequently, to be honest with you. Are they transitory? This would mean that they are here 1 minute. This would mean they're fleeting. They're here 1 minute and then they're gone the next. But we know that's not the case. They're still here. They've been here for 360 million years. So we could consider them remnants of this ancient time. They have remained from a prior time. In that way, we can consider them remnants. They're still here. They've remained. They're what remains, the remnants of a past time. All right, so that's a science passage. We'll move on to the next one here. So I'm going to load this one up. This next science passage is about fracking. It's a paired passage. Haley, I hope you have both of these. I'm going to try to bring it up. Hopefully you have the next passage in here. All right, so here we are to this one. Right here on this fracking passage. And we have a paired passage now, so we have a pair of science passages. So turn to these, and it says passages 22 through 31 are based on the following passages. So this first one says it's adapted from an article published in 2012 on a new method of natural gas extraction, hydraulic fracturing, or fracking for short. And then the second passage says it's written by a gentleman called Matthew Ferenc, and he will discuss the impact of hydraulic fracturing on his family farm in rural areas in Pennsylvania. So we have a couple passages here, but before we even try these, I just want to give you a quick strategy for the chat room. So here's the strategy. Read passage 1, answer passage 1's questions. Then go back and read passage 2 and answer passage 2's questions. So let's take a look at the questions real quick. What if I just read passage 1? I didn't even read passage 2. How many questions could I answer? Well, I could answer this one. I could answer this one. I could answer this one. I can answer this one. This is too far. This is from passage 2. I can't answer 26, but I could answer 27. So 1, I'm just going to count these up. I could mention, this is passage 1 still. So I could answer 27. I'm just going to count them real quick. So that's 1, 2, 3, 4, 5, or half of them. So if there are 10 or 11 questions total, I can answer half of them just from reading the first passage and then answering the question. So the strategy, the passages, oh wait, pages weren't printed front and back, so I don't have the first half of the reading. I don't have half the questions. Oh no. Haley, I apologize. Oh my, I feel really badly about this. Well, this is the last. I think this is the last one we're gonna have time to do anyway. I'm gonna leave this up on the screen so you can read it, and I'll just give you the answers for the final one, and maybe I'll try to bring it, or we'll try to get you a good version of this packet. I apologize, Haley. I don't know what happened there. That sounds pretty weird. I'll leave this up, and then this will be the last thing we do today. So just let me know, Sophia, when you're finished with this, and we'll go over it. Haley, do what you can. Try as many as you can. I'll leave up as much on the screen as I can to help you, but if it becomes impossible or if it becomes annoying, don't worry too much about it. And I apologize. Okay, so we are starting to run out of time, it appears. I'll leave these questions up for a minute, though. Yeah, we're running out of time, so I think I'm going to start just going over these questions. I apologize, Haley, for the packet mess. But I'll try to keep this as much on the screen as I can to help you. At least go over these questions. Alright, so let's look at the first one. And it is about passage 1. Passage 1 focuses primarily on which which aspect of natural gas extraction. So passage 1 doesn't seem to focus so much on likelihood for disaster. It mentions it, but it's not a focus. It's in answer choice C is passage 2. So that's kind of why I like the splitting up the passages strategy. I like reading passage 1, answering passage 1's questions, then reading passage 2 and then answering passage 2's questions, because we haven't even read passage 2 at this point, so you're not going to be tempted into picking answer choice C. So answer choice C is all about passage 2. We know passage 2 is about the inequality of the drilling locations. Passage 1 seems to be mainly focused on the energy gains. This seems to be the pro-fracking passage, at least in my opinion. The first passage seems to be pro-fracking, and lines 14 to 16 are the best evidence for these energy gains that could be made in this industry. I'm just going to read these lines. As a result of this technique, shale gas production in the U.S. has increased from 1 to 4.8 trillion cubic feet between 2006 and 2010. So that is good evidence for the potential energy gains that can be had from fracking. 24 says, passage 3 of paragraph 1 attempts to dispel what fears regarding shale gas extraction. Just going to count the paragraphs. So that's 1, 2, 3. So what are we trying to dispel? What fears are we trying to dispel with paragraph 3? I'm just going to maybe highlight this part here. So despite the concerns of some, no evidence has been recorded of fracturing fluid migrating to underground aquifers during the hydraulic fracturing process. That would be an ecological consideration. Wouldn't be a health issue or anything else. That's the idea that the fracking fluid could migrate to underground aquifers, but there's no evidence of this. So that would be an ecological concern. And passage 1 attempts to dispel that fear. So how does the EPA revision strengthen the claims of passage 1? Well, here's the EPA revision. The EPA has released new methane emissions estimates from 1990 through 2010 that are 20% lower than had previously been thought. So 20% is pretty big. Natural gas emissions are decreasing according to our graph. It looks like as shale gas production goes up, methane emissions are going down, but that's not what they're asking about. The EPA revision, not the graph. This is the EPA revision, this 20%. So they've overestimated natural gas emissions by 20%. Would you consider that rigorous? 20%? I would. 20% is huge. So that's answer choice B. They never claim that natural gas is a clean energy source, and they don't mention that natural gas emissions are lower than that of coal, even though I believe that's true. 26 says, as used in line 72, poised means what? Well, that's from the second passage. I might temporarily, I'm going to wait on this one until I do. Let's answer the last question from the first passage first. So 27 is still about the first passage, so I'm going to answer this one first. Let's talk about viable in line 26. Though not perfect, shale gas promises to be a viable bridge to more environmentally sustainable forms of energy production. So I'm just going to reread the words back in the sentence. Only one should work. Let's try variable. Though not perfect, shale gas promises to be a variable bridge to more environmentally sustainable forms of production. That makes no sense. Variable bridge is out. analyzed past tense. I'm not even going to try that. That would make no sense. Let's try feasible. Though not perfect, shale gas promises to be a feasible bridge, right? A viable bridge to more environmentally sustainable forms of energy production. And that makes perfect sense. So feasible doesn't mean viable. I think your plan is viable. I think it's feasible. It could perform. It could be done. 28. Both passages draw. Let's go back. I skipped one. 72. Poised. So what does poised mean in line 72? Here it is. Sometimes things go wrong with the drilling, and there has been no shortage of attention to wells gone bad and streams that can be set on fire and the clandestine ways of an industry poised to make a ton of money on a ton of gas. Let's read the words back in the sentence. I am going to read balanced. Back in the sentence. All right, so the clandestine ways of an industry balanced to make a ton of money on a ton of gas doesn't quite make sense. Almost makes sense. They like to pick near words. They like to pick words that would almost make sense. I'm going to try positioned. I feel that this will be a much better word here. Let's try positioned. Okay, so the streams that can be set on fire and the clandestine ways of an industry positioned to make a ton of money on a ton of gas. That makes perfect sense. Read the words back in the sentence. It's not cheating. Very helpful. So 26 was B. 28 says both passages draw attention to what aspect of shale gas extraction. They both talk about the potential for accidents. Passage 1 downplays this potential for accidents, and passage 2 has its own unique voice on the matter, but they both talk about it. You could set the streams on fire perhaps in passage 2, and passage 1 talks about the fact that people are worried about the ecological concerns, but the fracking fluid has not migrated to underground aquifers. 29, the author of passage 2 would most likely say, what about this part from passage 1? Well, here is the part from passage 1, lines 29 through 31. That's this part. I'm just going to highlight it. So, this part right here. Okay, so what would this guy say about this statement by the other author? That's what we're trying to say. What would Matthew Ferencz, the person who wrote passage 2, say about this claim? I'm going to read the claim from passage 1. Fears over leaked methane gas as well as contamination from hydraulic fracturing fluid have led to a moratorium on the process in some areas. A moratorium is just a ban. So this process has been banned in some areas. What would the author of passage 2 say about that idea? The fact that fracking has been banned in some places. Well, we know that this passage 2 is all about the inequality. The inequality of the fracking locations and the destruction of kind of this family farm and this landscape. So what would Matthew Ferencz say about the bans that are placed on hydraulic fracturing? He would say, well, you know what? Those types of bans occur in wealthy areas. They don't occur here. They don't occur in Appalachia. So now let's find some evidence that supports this idea that perhaps wealthier areas have bans on fracking, but less wealthy areas, they don't have bans on fracking. That's right here, lines 74 through 75. I'm going to read these lines. All right. I think about how the spoiling of lives happens so often in places considered second rate, like Appalachia. That our mountains are fracked is certainly related to the kind of cultural power we don't carry. We never quite catch a break in the natural circulation of stereotypes. Hillbillies, we are called misfits of the mountains. So that's the idea that fracking bans occur in wealthier areas, not in poorer areas. And then lastly, the passage and the graph which support which of the following statements. So I know the EPA overestimated methane emissions by 20%. So these under answer choices, B and D, are out immediately. It's either A or C. Now I'm just going to look at the graph. What does the graph say? So the graph, as I said earlier, it looks like as shale gas production goes up, the shale gas emissions have gone down over time. So I'm just going to pick the answer choice that has both of those in it. We've overestimated methane emissions and total emissions have declined over time. So I don't think we have time to do this next passage. I'm just going to give you the answer choices in case you want to do this dolphin passage at home. Sophia, I know that Haley, you might not even have half of this passage. I apologize. We'll try to get you the right passage, or the right materials. I don't know what happened there. So here's our dolphin passage. I'm just going to put the answers here on this page, and if you want to try this dolphin passage, or if you can try the dolphin passage, you can check your work later. Maybe write these on the front of your packet, Sophia, so you won't be looking at them if you want to try this one at home. But I'll give you the answers for 42 through 52. All right. All right, this one, see. All right, so those are the answers for the Jacques Cousteau's dolphin passage. So I'll just leave those up for you for a minute so you copy them down. And if you have any questions, you can put them in the chat room, Sophia or Haley. Haley, I apologize again for the packet. We'll get you a good copy of it at some point, just so you can look over it. Thanks for reading off the screen and doing your best today, best as you could. Sophia, yeah, thank you so much for being a great group. Margot's probably watching this later. If you have any questions, Sophia, you can put it in the chat room. Haley, if you have any question, you can put it in the chat room. Mrs. Hessler had to leave for the evening, but I can do any math question that you may have or any kind of English question you may have if you have any questions. Otherwise, you can just sign yourself off for the evening. That's all that we have for today. So sorry we went a little bit over. It's just because that circle lesson math went way over time today. So I apologize. If you have these copied down, you can just sign yourself off for the evening, and we'll see you next time. We will grade practice tests if you mail them to Mrs. Hessler. Her address is on the website, so you can always find it there. And just waiting for any questions, or you just say goodbye or good night, and I'll sign us off. There's a little bit of a lag here too, so I realize. No questions? I don't see any questions. Seems like everyone's good. Alright, well, if you guys are good, then I'm going to sign us off for the evening. Thanks again. Thanks for being such a great group, and thanks, Haley, for being understanding. I apologize for that printing error. We'll see you guys next time. We're grading practice tests as they come in, and good night.